When a ray of light travels from optically denser medium to rarer medium, a part of light is refracted into the second medium and another part of light is reflected back into the same medium. It is called internal reflection of light. From this, it is clear when the light travels from denser to rarer medium, it is neither totally refracted nor totally reflected. It is partially refracted and partially reflected. But if the angle of incidence is increased beyond a particular limit, then the incident ray of light totally reflected back into the same denser medium. This idea helps us to understand the concept of total internal reflection. Now let us have little more detailed discussion about total internal reflection of light. When a ray of light travels from optically denser medium to optically rarer medium, then after refraction, it goes away from the normal. Let us understand this with the help of this diagram. It is incident ray of light and it is refracted ray of light. I1 be the angle of incidence and R1 be the angle of refraction. R1 is greater than I1. Now suppose we increase angle of incidence, then angle of refraction will also increase. Let I2 be the angle of incident in the case 2. Then corresponding angle of refraction is R2. Now, if we further increase the angle of incidence in the denser medium, then angle of refraction also increases in the rarer medium. Now, if we further increase the angle of incidence, then the angle of refraction would become 90 degrees. Here, the refracted ray would be tangential to the interface XY, and the angle I4 is called critical angle, and critical angle is denoted by IC. Now we can define critical angle. The angle of incidence for which the angle of refraction is 90 degree is called critical angle. Critical angle is denoted by I and suffix C. Now, if we further increase the angle of incidence, that is angle of incidence greater than critical angle, then the light is totally reflected back into the denser medium. Now, no light is traveling to the rarer medium. This situation is called total internal reflection. Now let us define total internal reflection. When a ray of light traveling through a denser medium is incident on the surface of rarer medium, and if at an angle of incidence greater than the critical angle, there is no refraction of light in the rarer medium, the ray is totally reflected back in the same denser medium. This phenomenon is known as total internal reflection. Conditions for total internal reflection to occur. First one, the ray of light must travel from optically denser medium to optically rarer medium. And the second condition is the angle of incidence in the denser medium must be larger than the critical angle for given two pair of media. Now, let us talk about applications of total internal reflection. That is, how total internal reflection is observed in nature. Second, what are technological applications of total internal reflection? Shining of diamond. Shining of diamond is due to phenomena of total internal reflection. The light suffers total internal reflection from many cut phases before coming out. This gives sparkling shine to the diamond. Now, let us understand one more natural observation of total internal reflection is mirage. During summer hot day, especially in deserts, air near the ground becomes more hotter than air at upper heights. As we go up height from the ground, air becomes optically denser medium and air near the ground becomes optically rarer medium. When air close to the ground becomes hot, light bends gradually. Due to this, light refracted away from normal, and at certain interface, the angle of incidence becomes greater than critical angle, and due to total internal reflection, apparent inverted image of object is seen by the observer. This phenomena is called mirage. Now, let us talk about technological application of total internal reflection, that is fiber optics or optical fiber. Fiber optics transmit data in form of light signals from one point to another point by using glass or plastic fibers. In this, light is introduced at one end of fiber at certain pre-decided angle. Light introduced in the fiber suffers repeated total internal reflections along the length of fiber and finally get transmitted to the other end of the fiber. Fiber optics are used as a cable for internet and computer networking, 2 in medical such as endoscopes to carry out surgery and in biomedical sensors. Third one, remote sensing such as monitoring oil and gas pipelines from a distance is possible by using fiber optics. In electric vehicle charging system, in defense such as laser technology, weaponry, high-speed satellite communication, and high-speed radar system. That's all in this video. I hope the concept regarding total internal reflection are very much clear now. Still, if you have more doubts about total internal reflection, then please communicate with me on my email address provided in the description box. Meet you again with another topic. Till then, wish you good luck. Before saying goodbye, I would like to request you like, share and subscribe the channel. Bye bye. Meet you again with another topic. Till then, wish you good luck.